In this video, we will discuss about end of term 2 examination. So here you can see subject physics and grade 9 advanced McGraw-Hill. There will be 25 questions and all the questions will be MCQs. And mark for each question is 5 marks for each question, and there will be 25 questions. All questions will be MCQ. Then the total marks is 100 and the exam duration is 120 minutes, and the exam will be on the Swift Assess platform. So here question number 1, recall addition and subtraction of vectors in one dimension. To learn that, you can read page number 122 of the textbook, and there is a section review on page number 129, and you can practice that page number 129. So if two vectors are in one dimension, how to add or subtract these two vectors, that first we will discuss that, and we will go to the section review in page number 129 after discussing how to add vectors in one dimension. So now we will use this Microsoft whiteboard to discuss how to add vectors in one dimension. Yes. So here, if we have one vector along this direction, for example, this is a 3 Newton force, or the magnitude of this vector is 3, and another vector, its magnitude is 2. So how to calculate the sum of these two vectors? Sum that we usually represent by the letter R means resultant. Sum we call the resultant. As these two vectors are in the same direction, to find the resultant, we simply add this. So 3 plus 2, that is equal to 5. Then if two vectors are in the opposite direction, for example, we have a vector, its magnitude is 7, and another vector, its magnitude is 3, but they are in the opposite direction. So then what will be the resultant? Means sum of these two vectors. So 7, we will add this to the other vector, 7 plus this vector 3 is to the left side, so we will take it as negative. So negative 3. 7 plus negative 3, that is 4. This is how we add vectors when they are acting in one dimension. Now we will go to the page number 129 to answer the section review in chapter 5. Page number 129. 128, 129. Okay. So here, question number 11 in section review, main idea, find the components of vector M as shown in the figure. So here there are 3 vectors given, M, K and L. So first we need to find the component of vector M. So here vector M, we know that every vector has X component and Y component. So this vector M, you can see here M, the value of the vector M is 5 Newton. So we will divide this vector M into 2 components, Mx and My. So what is the value of Mx and My? Mx means the X component of this vector M. So I will write here, this is the Mx. Mx you can calculate using the equation Mx is equal to M multiplied cosine of the given angle. So here the given vector or the value of M is 5. So 5 multiplied cos 37, and My means the y component of this given vector, that is 5 multiplied sine given angle, that is 37. So mx, that is equal to 5 multiplied cos 37, and my is 5 multiplied sine 37. Now we will calculate and write these answers. 5 multiplied cos 37, that is equal to 5 multiplied cos 37, that is 3.99 Newton. So I will round this to 4.0 Newton, 4.0, okay, 4.0, so no unit because no unit is mentioned there. Then the value of my, that is 5 multiplied sine 37, that is equal to 3.00. So I will write 3.0. So now we will go to the next question. Here. Question number 12, components of vectors. Find the components of vectors k and l in figure 9. The same figure, so I will take a screenshot again. So in this we need to calculate the components of vector k and l in question number 12. Okay, now we are discussing this question, question number 12. Find the component of vector k and l. So if I write vector k, the value of vector k is -4. So kx, x component, and ky, y component, you can see vector k is along the x direction, right? If a vector is along the x direction, means if it is in the horizontal direction, then it will have only the x component. It will not have y component. So its x component, that is equal to -4, because this vector is along the x direction. So its y component will be 0. In same way, the x component of L, that is equal to 6. X component of the vector L is equal to 6. And what will be the y component of vector L? Y component of vector L will be 0, because this vector L is along the x-axis. So it will have only the x component, its y component will be 0. Let us move to the next question in the section review. Question number 13, vector sum. How to calculate the sum of the vectors. Find the sum of all three vectors shown in this figure. So here we have three vectors, right? So now we are discussing question number 13, how to calculate the sum of the vectors. Okay, question number 13, vector sum. Find the sum of three vectors shown in figure 9. So here vector m, vector k, and vector l. M I will divide into two components. So mx, that we calculated to 4. And my also we calculated, and we got 3 in the previous question. So we will add all these. Then this 4 and 4, positive 4 and negative 4, that will be cancelled. And here what is remaining? Only 3 is remaining. So that 3, and here we have a 6. Vector L is 6. So sum of vector like k plus m plus l, that is equal to this 6 I will draw here, 6, and this -4 and this 4 cancelled. So here I have a 3 here. Then what is the resultant? Resultant will be, or sum will be, sum or resultant, okay, both are same. From the starting to the end, right, from the tail of the first vector to the head of the last, means to the tip of the last. So this is the resultant. So as this angle is 90 degree, you can use Pythagorean theorem to calculate this sum. So here sum of these two vectors 6 and 3, that is equal to square root of 6 squared plus 3 squared, that is equal to Let me use my calculator. Square root of 6 squared plus 3 squared, that is equal to 6.708. So we will write 6.7 is the magnitude of the sum or magnitude of the resultant. Now we have completed discussing this question number 1. Now we will go to the question number 2. Identify the factors that friction force depend on. So we know that when one object is moving over a surface, then there will be an opposing force between the surface of contact, right? Means between the surface of the object and the surface of the platform. So that opposing force is called frictional force. Then what are the factors on which a frictional force depend on? Frictional force, we have this equation to calculate friction. Friction that is equal to friction, I will represent by the letter F, that is equal to coefficient of friction multiplied normal force. So from this equation we can understand that frictional force depends on coefficient of friction and normal force. So what are the two factors on which frictional force depend on? One is coefficient of friction and second is normal force. So coefficient of friction which actually depend on the nature of the surface. So we can write a frictional force always depend on two factors. One is nature of the surface. Nature of the surface in contact means the surface of the moving object and the surface of the platform. So the frictional force depends on the surface in contact. Second, the frictional force depends on the normal force. So these are the two factors on which frictional force depends on. And we know that this normal force, the same equation we can write, means on a horizontal surface, normal force is always mg, right? So we can write frictional force that is equal to coefficient of friction multiplied normal force, that is normal force is equal to mg, mass multiplied value of g. G is a constant, its value is 9.8. So from this equation you can see that frictional force depends on two factors. One is nature of the surface in contact and the second is the normal force. And the normal force depends on the mass. So we can say frictional force depends on the nature of the surface or nature of the surface and normal force, or we can say frictional force depends on the nature of the surface and mass of the object. Because if the mass of the object is greater, then normal force is greater. So these are the two factors, okay, on which frictional force depends. One is the nature of surface in contact and normal force. As normal force depends on mass, so we can say that mass also is a factor on which friction depends. Now I will go to the third question. Now we have discussed this question number 1 and question number 2. And to know means to get more information about the question 2, you need to read page number 131 and 132 of your textbook. And now determine the resultant of two or more vectors algebraically by adding components. So now we will discuss example 3 from page number 133. Now we will go to the page number 133 and we will discuss example 3 there in page number 133. I think this is stat 1, yes. So here, page number 133, example 3. A balanced friction force, you push a 25 kilogram wooden box across a wooden floor at a constant speed of 1 meter per second. The coefficient of kinetic friction that's given. How large is the force that you exert on the box? So here there is a box on a floor. So this is the box here, and you are applying a force on the box, means you are pushing the box, so the box is moving at a constant speed of 1 meter per second. So there will be a frictional force acting between the surface of contact, and that frictional force will be always in the opposite direction of motion, means or opposite to your applied force. And here you need to calculate how much force you are applying on the box. You need to calculate how large is the force that you exert on the box. So you need to calculate the applied force. Applied force is always equal to frictional force plus net force. Net force, I will write mass into acceleration from Newton's second law. So frictional force, that is equal to, we have the equation for frictional force, that is coefficient of friction multiplied mg. Okay, means no, coefficient of friction multiplied normal force is the equation for friction. Normal force is if the surface is a flat surface, horizontal surface, not an inclined surface, then normal force is equal to mg. So directly I will write friction is mu mg plus ma. Ma is the net force. So what is the value of mu? The value of mu is 0.2, that is given here in the question. Coefficient of friction is 0.2. Multiplied m, here it is given mass of the box is 25 kilogram. 25, and you know the value of g, right? Value of g on the surface of the earth, it is always 9.8 plus mass multiplied acceleration. Mass is 25 multiplied acceleration. Here the box is moving at a constant speed. If any object is moving at a constant speed or at a rest, then acceleration is equal to 0. So when I calculate this, I will get the answer 49 Newton. I have done this before, so I know this answer is 49 Newton. So 49 Newton is the value of the applied force. Now we will go to the next question. Now we have discussed here, where is our EOT? Yes. Now we have discussed question number 3 also, that is example 3 in page number 133, done with that. And question number 4, recall that for an object to be in equilibrium, the net force acting on it should be 0. That you know that, right? Equilibrium means the object is at rest or moving at a constant speed. That is, the net force acting on the object is 0. Okay, so acceleration will be 0, right? So the condition for equilibrium is acceleration of the object must be 0. For the acceleration to be 0, the net force acting on the object must be 0. Net force is 0 means the opposite forces must be equal. Then determine the magnitude and direction of the resultant force of two vectors in one dimension using trigonometry and Pythagorean theorem. That is question number 87 in 146. Question number 87, 146, I have explained in very detail in another video, so you can watch that video because otherwise this explanation will be very lengthy. I will explain this here. So I am not explaining that here, you can watch that video. Question number 5, illustrate graphically the addition and subtraction of vectors in 2 dimensions. Okay, stated explicitly in the textbook, page number 123 and 137. So if vectors are acting in 2 dimensions, then how to calculate the resultant? So here we have 3 different methods to calculate the resultant if vectors are acting in 2 dimensions. First is we will use Pythagorean theorem. Okay, one is using Pythagorean theorem. Pythagorean theorem. Second is law of cosine. Law of cosine. And number 3 is law of sine. So when do we use Pythagorean theorem? We use Pythagorean theorem if 2 vectors are acting perpendicular to each other, means if the angle between the two vector is 90 degree, then if it is vector A and vector B, then the sum of these two vector is equal to square root of vector A square plus B square. Then law of cosine, if the angle between two vector is not 90 degree, for example this is vector A and this is vector B, so this angle between these two vector is not 90 degree, then we will use Pythagorean theorem, we will use law of cosine, and law of cosine states that next, in which situation we will use law of cosine? We have two vectors, for example, vector A and vector B. So this angle between these two vectors is not equal to 90 degree. In those situations, we will use law of cosine. Law of cosine means by using law of cosine, that is R is equal to square root of A square plus B square minus 2ab cosine theta. This is the equation to calculate the resultant, to calculate the sum of two vectors using cosine law. And law of sine states that one side divided by the sine of the opposite angle, that is equal to another side divided by sine of the opposite angle to this side. So like that, okay, this angle will be different. So angle instead of theta, I will write sine A, sine B, like that. Then, well, at what situation we use law of sine? Law of sine we use if two angle and one side is given, okay, two angle and one side is given, then we use law of sines, and we use law of cosines when two sides and one angle given, then we use law of cosine. So here you can see there is only one angle, two sides A and B. Here you can see one side. One side must be given, then only you can use this. So if one side is given, one side and two angle given, then you can use this law of sine. Okay, now we will go to the next one. So now we have discussed this. Now we will go to question number 6, that is determine the magnitude and direction of resultant of two vectors in two dimension. Trigonometry, Pythagorean theorem, question number, example 1 in page number 124. So page number 124, example 1, 124, 126, 125, 124. Yes. So this is a very simple question, a direct question here. You need to directly use the equation. So here, finding the magnitude and sum of two vectors, find the magnitude and sum of 15 kilometer and a displacement of 25 kilometer displacement when the angle between them is 90 degrees. So 15 kilometer and 25 kilometer when the angle between them is 90 degree. So if the angle between two vectors is 90 degree, then we will use Pythagorean theorem. The sum is equal to square root of 15 square plus 25 square. This is commutative, okay? 25 square plus 15 square, both same thing. So 15 square plus 25 square, when you do the calculation, you will get the answer. I am not spending time to do the calculation. Use your calculator, okay, and find the answer. So second, if the angle between them is 135 degree, then how to find the resultant? For example, vector A 15 kilometer here and another 25 kilometer like this. And if this angle is 135 degree, then how will you calculate the resultant of these two vectors? In that case, we will use law of cosine, because two sides and one angle given, and that angle is not equal to 90 degree. So the sum is equal to, according to law of cosine, square root of 15 squared plus 25 squared minus 15 multiplied 25 multiplied cos given angle cosine 135. Use your calculator, do the calculation, you will get the answer. Okay, I'm not spending time to do the calculation. Now let us move to the next question. Now we have done with the question number 6, and now we are going to question number 7. Define friction as a type of force between two touching surfaces and determine its direction. The direction of friction will be always opposite to the applied force, or we can say direction of friction is always opposite to the direction of motion of the object, and frictional force is the opposing force that acts between two surfaces in contact when an object has a tendency to move, or if the object is moving. If the object is not moving but it has a tendency to move, then that friction is called static friction, and the friction acting while the object is in motion is called kinetic friction. Then question number 8, determine the component of a vector in Cartesian coordinate system using trigonometry. So in that case, we will draw a Cartesian coordinate system here. So this is the, okay, what happened? Yes. So this is the x-axis, and this is the negative x-axis, this is y-axis, and this is the negative y-axis. Then if I draw a vector here, for example, this vector is a 5 Newton force, and this angle theta, that is equal to 50 degree. So we can divide this vector into two components, component along the x-axis and component along the y-axis. Component along the x-axis, that I will just write x component, that is equal to 5 multiplied cos 50, and its y component, that is equal to 5 multiplied sin 50, cos 50, okay. Then if, now I will erase this, and if this vector, now I am drawing that vector here, and see, always you need to take the angle from the positive x-axis. This is the positive x-axis. Sometimes this angle will be given, for example, this angle is given as 30 degree. So its x component will be along this side and y component will be along this side. So to calculate this x and y component, you should not use this angle 30, you have to use the angle from the positive x-axis. So you need to use 90 plus 30. 90 plus 30 is 120, right? So if this vector is 5 Newton, then its x component, I will write x. That is equal to 5 Newton multiplied, x component 5 Newton multiplied cos the total angle. Okay, angle you need to take from positive x-axis. 90 plus 30, that is 120. And its y component is 5 multiplied sin 120. Okay, so you need to always